In this video, we are given the graph of f prime, the derivative of function f. I will show you how to sketch a possible graph of the original function f. The key is this chart that shows the graphical relationship between f, f prime, and f double prime. Take my advice, memorize this chart right now. You will be using this information throughout AP Calculus. In fact, pause the video and see if you can write this chart on a piece of scratch paper from memory. Since we're given the graph of f prime, let's start with the f prime column of the chart. Let's divide the graph of f prime into intervals of increasing and decreasing. See how f prime is rising in this first interval? So f prime is increasing from here to here. It is decreasing from here to here, and it is increasing again from here on. But looking back at the chart, remember, anywhere f prime is increasing, that means the original function f is concave up. If f prime is decreasing, the original function f is concave down. So, function f will be concave up in this interval, concave down in this interval, and concave up in this interval. Moving down the chart, let's now divide f prime into intervals where it is positive and negative. Notice how the graph of f prime begins below the x-axis and then it passes above the x-axis right here. For the rest of the graph, it stays greater than or equal to 0. So for the first interval, f prime is less than or equal to 0. And then for the rest of the graph, f prime is greater than or equal to 0. So looking back at the chart, anywhere f prime is positive, the function f should be increasing. And if f prime is negative, f should be decreasing. So function f will be decreasing in the first interval and increasing for the rest of the graph. There's one more thing we need to pay careful attention to. Remember that f prime represents the slope of function f. So anywhere f prime is 0, function f should have a horizontal tangent line. So you can see that f prime is 0 here and here. So when we draw function f, we need to make sure that there's a horizontal tangent line in these two locations. So I think we're ready to start drawing the graph of function f. Let's graph function f one interval at a time. So in this first interval, f should be decreasing and concave up, and also at the end there should be a horizontal tangent line. So here we go, decreasing, concave up, and then ending at a horizontal tangent line. When I'm sketching the final graph, I start a new interval anytime there's a change in either the concavity or the decreasing and increasing. So the next interval will stop right here where it switches from concave up to concave down. In this interval, function f should be increasing and concave up with no horizontal asymptote at the end. So here we go, increasing and concave up. So something just like that. In the next interval, f should be increasing, concave down, and it should end at a horizontal tangent line. So here we go, increasing, concave down, and ending at a horizontal tangent line. For the rest of the graph, function f should be increasing and concave up. So here we go, increasing and concave up. And that's it. This is a possible sketch of the original function f. There are many versions that you could possibly draw. As we do problem number 2, remember that we are looking at the graph of f prime. These segments represent slopes, and we are trying to somehow work backwards to imagine the original function that had these slopes. Because f prime has these linear intervals, we're going to have an extra step to watch out for. Looking at the chart, let's begin by dividing f prime into intervals of increasing and decreasing. See how f prime is falling from left to right in this first interval. So f prime is decreasing from here to here. Then it is increasing from here to here. In the last interval, it is neither increasing nor decreasing. Remember that where f prime is increasing, f will be concave up. Where f prime is decreasing, f will be concave down. So function f will be concave down in the first interval and concave up in the second interval. Because function f is neither concave up nor concave down in the last interval, that means it must be linear. Next, let's go back and divide f prime into intervals where it is positive and negative. F prime starts out above the x-axis, then it falls below for this interval, and then it's back above the x-axis for the rest of the graph. So f prime is greater than or equal to 0 from here to here. It is less than or equal to 0 from here to here. And it is greater than or equal to 0 from here on. But remember that where f prime is positive, function f is increasing. Where f prime is negative, f is decreasing. So function f should be increasing in the first interval, decreasing in the second interval, and then increasing again in the third interval. Before we can sketch the graph of function f, we need one more piece of information. Remember that f prime represents the slope of function f. So wherever f prime is 0, the slope of f should be 0. In other words, there should be a horizontal tangent line here and here. Okay, let's go ahead and start sketching the graph of function f one interval at a time. Notice that there's nothing telling me exactly where to start drawing in terms of how high or how low. So you can really just start drawing wherever you want. So I'm just going to start drawing right here. So in this first interval, f should be increasing and concave down. And notice that we should end the interval at a horizontal tangent line. So here we go. Increasing, concave down, and then ending at a horizontal tangent line. In the next interval, f should be decreasing and concave down, with no horizontal tangent line at the end. So here we go. Decreasing, concave down. In the next interval, f should be decreasing, concave up, and end with a horizontal tangent line. So here we go. Decreasing, concave up, and ending at a horizontal tangent line. For this next interval, f should be increasing and concave up with no horizontal tangent line at the end. So here we go, increasing and concave up. In this last interval, function f should be increasing and linear. So this is special. A linear function means that there is a constant slope, and we can read that constant slope right off the graph of f prime. So in this interval, function f should have a slope of 2. So let's draw function f, but let's be careful to draw it so that it has a slope that is pretty close to 2. So in my mind, I'm thinking, like up 2 over 1. So I'm estimating, but this should be pretty close. And that's it. This is a possible graph of the original function f. Ooh, number 3 should be fun. Look how curvy this is. Let's start off by separating the graph of f prime into intervals of increasing and decreasing. F prime is increasing here and here and here. F prime is decreasing here, here, and here. Remember that wherever f prime is increasing, f will be concave up. If f prime is decreasing, f will be concave down. So function f will be concave up in the yellow intervals and concave down in the blue intervals. So now we will divide f prime into intervals where it is positive and intervals where it is negative. We see that f prime is below the x-axis in this interval, in this interval, and in this interval. F prime is above the x-axis from here to here, and from here all the way to here. Remember that wherever f prime is positive, f will be increasing. Anywhere f prime is negative, f will be decreasing. So function f will be decreasing in the blue intervals and increasing in the yellow intervals. One more thing, since we are given the graph of f prime, we know where the slope will be 0. So function f should have a horizontal tangent line here, 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 and here. So function f is going to have just a bunch of small intervals. Remember, we will start a new interval anytime something changes. If the graph goes from decreasing to increasing, new interval. If it changes from concave up to concave down, new interval. So let's just graph function f one interval at a time. So in this first interval, f should be decreasing and concave up, and it should end with a horizontal tangent line. So here we go. Decreasing, concave up, and ending at a horizontal tangent line. This next interval is very narrow, but that's okay. It should be increasing and concave up with no tangent line. So here we go. Increasing, concave up, no tangent line. The next interval should be increasing, concave down, and it should end at a horizontal tangent line. So here we go. Increasing, concave down, ending at a horizontal tangent line. In this next little interval, function f should be decreasing, concave down, and it will not end at a horizontal tangent line. So here we go. Decreasing, concave down. In the next interval, f should be decreasing, concave up, and it should end at a horizontal tangent line. So here we go. Decreasing, concave up, and ending at a horizontal tangent line. In the next interval, f should be increasing, concave up, with no horizontal tangent line at the end. So here we go. Increasing, concave up. In the next interval, f should be increasing and concave down, and it should end at a horizontal tangent line. So here we go. Increasing, concave down, and ending at a horizontal tangent line. This really feels like we're playing a game. Isn't this fun, you guys? So in this next interval, it should be increasing, concave up, with no horizontal tangent line at the end. So here we go. Increasing, concave up. Hey guys, I'm noticing a small mistake I made at the beginning of this problem, and I don't want to redo the entire problem, so I'm just going to fix it. Back when I was dividing f prime into intervals of positive and negative, I said that f prime would be positive from here to here, but it actually should have been to here where it crosses the x-axis. So I need to take this increasing interval and stretch it out to this line. So that means I have two more intervals to do. In this next interval, f should be increasing and concave down, and it should end at a horizontal tangent line. So here we go, increasing, concave down, ending at a horizontal tangent line. And in the last interval, it should be concave down and decreasing. So here we go, concave down and decreasing. And that's it. This is a possible graph of the original function f. Okay, well number 4 looks easy compared to number 3. Let's start by separating f prime into intervals of increasing and decreasing. So we see that f prime is increasing from here to here. It is decreasing from here to here. And it is increasing again from here on. Remember, anywhere f prime is increasing, f will be concave up. If f prime is decreasing, f will be concave down. So function f will be concave up in the yellow intervals and concave down in this blue interval. Now let's divide f prime into intervals of positive and negative. We see that f prime is below 0 from here to here, but then it is greater than or equal to 0 for the rest of the graph. Remember that anywhere f prime is positive, f will be increasing. If f prime is negative, f will be decreasing. So function f will be decreasing in this blue interval and increasing in this big yellow interval. One more thing, since f prime represents the slope of function f, we can easily see where f will have a slope of 0. So function f should have a horizontal tangent line here and here. So we are ready to graph function f one interval at a time. In this first interval, it should be decreasing and concave up, and it should end at a horizontal tangent line. So here we go. Decreasing, concave up, and ending at a horizontal tangent line. In the next interval, it should be increasing and concave up with no horizontal tangent line at the end. So here we go. Increasing and concave up. In the next interval, it should be increasing and concave down with a horizontal tangent line at the end. So here we go. Increasing, concave down with a horizontal tangent line at the end. And then in the last interval, it should be increasing and concave up for the rest of the way. So here we go, increasing and concave up. So there you go. This is a possible sketch of the original function f. This has been so much fun. I'm almost sad we're at the last problem. Let's start by dividing f prime into intervals of increasing and decreasing. We see that f prime is decreasing in this first interval. So it's decreasing from here to here. In the next interval, it's neither increasing nor decreasing. So I'm just going to leave that blank for now. Then it is increasing from here to here. And then again, in the final interval, it is neither increasing nor decreasing. Remember that where f prime is increasing, f will be concave up. If f prime is decreasing, f will be concave down. So function f will be concave down in the blue interval and concave up in the yellow interval. In these intervals where f is neither concave up nor concave down, function f is linear. Because we are given the graph of f prime, which represents the slope of function f, we can be more specific about these linear intervals. Function f will have a slope of -4 in this interval. And in this interval, function f will have a slope of about, I'm going to call it 1.5. Now let's divide f prime into intervals of positive and negative. We can see that f prime is above the x-axis in this first interval, and then it's below the x-axis for the middle interval and above the x-axis again for the last interval. Remember, anywhere f prime is positive, f will be increasing. If f prime is negative, f will be decreasing. And since f prime is the slope of function f, we can easily see where function f will have a slope of 0. So there will be a horizontal tangent line here and here. Now we are ready to sketch the graph of function f one interval at a time. To be honest with you guys, this is my third time starting this graph. I keep running out of space at the bottom. So I'm going to draw this graph as high as I can at the beginning. So in this first interval, f should be increasing and concave down, and it should end at a horizontal tangent line. So here I go. I'm going to draw it increasing, concave down, and ending at a horizontal tangent line, way up high. In this narrow interval, f should be decreasing and concave down. So here we go, decreasing, concave down. This next interval is why I needed all the space, and I fear we are still going to have to go off the graph. Because in this interval, the function is decreasing and linear, but more specifically, it has to have a slope of -4. We determine that because f prime right here, this horizontal line, is at -4. So I'm going to draw my line, but I need to draw it with a slope of -4. So it should be going at a rate of down 1 over 4, which is very steep. So it's going to be something like this. So you can see why I needed so much space. And then in the next interval, it continues decreasing even more. So it should be decreasing, concave up, and it should end at a horizontal tangent line. So here we go, decreasing, concave up, and ending at a horizontal tangent line. In the next interval, we are increasing and concave up. So here we go, increasing and concave up. In the last interval, f is increasing and linear, and specifically it should have a slope of 1.5. So that's 3 over 2. So I'm going to try to draw this in a way that it's going up 3 and over 2. So about like that. And that's it. This would be a possible graph of the original function f.